Today you are going to solve triangles, or you're going to be solving triangles using trig ratios. Solving a triangle means to find all the angle measures and side lengths. Solving a triangle means to find all angle measures and side lengths. And before I start doing problems, I just want you to write these rules down. Inverse trig functions. It's on the bottom of page 552. And it says that if the sine of an angle is equal to x, then sine to the negative 1 power of x is equal to the measure of the angle. It'll make a whole lot more sense in a few minutes. And you can continue this, but it also says that if cosine of angle A equals x, then cosine to the negative first power of x is equal to the measure of angle A. And the same is true with tangent. If the tangent of an angle is equal to x, then tan negative 1 of x is equal to the measure of the angle. And I find it very helpful, very helpful, if you can remember that when finding side lengths, use sin, cos, and tan. Those buttons, okay? And when finding angle measures, use and I'm just going to put second, meaning the second button. All right, or, no, I'm not going to say or yet. Use second sine, cosine, tan. Or it's sine negative 1, cosine negative 1, tan negative 1. That's what the second button gives you. The inverse function of sine, cosine, tangent. Yesterday you were finding side lengths and you used sine, cosine, tangent. You're still going to use the same ratios, the same concept, but in the calculator you're going to be using the second button when you're finding angle measures. Does everybody have that written down? So here's how it works. Let's say you're given this triangle. And here's your 90-degree angle. Angle 1 and angle 2. And then 6, 4.8, 3.6. You could be asked to find angle 1, find angle 2, or you could just be asked to solve the triangle. So in this case, let's find angles 1 and 2. Write the acronym on your paper if you haven't already done that. SOHCAHTOA. So let's find the measure of angle 1. Now, if you're given this picture and you're asked to find the measure of angle 1, they have given you all three sides. So you can pick any two sides to work with that you want. I'm going to pick, in relation to angle 1, I'm going to use opposite and I'm going to use adjacent. And if I'm using opposite and adjacent, I'm going to be dealing with tan. So here's how it works. If tan of angle 1 equals opposite 4.8 over 3.6, then the measure of angle 1 is going to be equal to tan negative 1, 4.8 over 3.6. Now, the easiest way to do this is to take your calculator and take 4.8 and divide it by 3.6. You should have 1.33 in your calculator?
Yeah.
All right. And then if you have the black calculator, push second tan. So the measure of angle 1 equals, we're going to round to the nearest whole number, 53 degrees. If you got a yellow calculator, you can just type second tan. You can just type this if you have the yellow calculator, in that order. Second tan, it's going to give you a left parenthesis. You could type 4.8 over 3.6 and push enter. And it's going to spit out 53 degrees. So either way. So if angle 1 is 53 degrees, can't you take 90 minus 53 and get angle 2? Because the acute angles of a right triangle are complementary. So what's 90 minus 53? 37 degrees. Anybody confused? All right, here's triangle MNO. M to N is 14.4. N to O is 27. And let's solve the triangle. So let's see, I'm going to find angle O first, right here. In relation to angle O, the sides that are given are opposite and adjacent. Opposite and adjacent is a tangent ratio. So the measure of angle O is going to be equal to tan -1 14.4 over 27. So in the black calculator, you have to type the fraction first. 14.4 divided by 27.53, and second tan. I'm rounding it to the nearest whole number. Does your calculator say 28 degrees? Okay. So the measure of angle O is 28 degrees. So 90 minus 28.
Oh, 62.
62. The measure of angle M is 62 degrees. All right, so what's missing? Yeah, N is 90, so you need the hypotenuse. There's two ways to find the hypotenuse. It's a right triangle. You could either use the Pythagorean theorem, or you could use sine, cosine, tangent. I think sine, cosine, tangent's faster. That's what you did yesterday, wasn't it? So now you can pick either angle and one of the two given sides to find the hypotenuse. So I'm going to use the 62 degree angle. And then let's see, I'm going to use opposite to find hypotenuse. Okay? So in relation to the 62, I'm using opposite to find hypotenuse. Opposite and hypotenuse is sine. So sine 62 equals opposite over hypotenuse, which is MO. Now yesterday we did it in like multiple steps, but you can kind of get a little quicker at this. You're going to multiply both sides by MO, right? And doesn't that cancel these two MOs? And then to get the MO by itself, you're going to divide by sine 62. So without doing a bunch of writing, MO is going to be equal to 27 divided by 62 sine. So 27 divided by 62 sine equals, that's 30.58. So this piece is 30.58. And that's the triangle solved. You found both of the missing angles and the missing sides. So you know all three sides and you know all three angles. Yes?
If you're using, okay, I tried doing it with O, and
Say that one more time. You tried doing it with angle O,
yes,
the 28.
yes.
All right.
And I came out with 30.67.
That's because everything's getting rounded here. This 28 degree angle was rounded from step number 1 to a whole number.
Yeah.
This 14.4 was probably rounded.
Would it still be correct or no?
It's close enough. You got 30.62, I got 30.58. We're using rounded numbers. So as long as you're within a degree, it's close enough.
Okay, because what I was thinking was that no matter which one you use, you're supposed to get the same answer. when
Not,
you're rounding it.
well, no, not when you're rounding. When you're rounding, you're cutting off,
Let's see.
you're cutting off this 30.58 that we had. If you go second, fix 8, your calculator is going to say 30 point, calculator says this, 5, 7, 939, 137. That's just what your calculator's showing. And we took all of this and we whacked it off. Okay? Which probably happened here. Which, since we whacked all of that off, we probably whacked off the same amount on the 28. And since we cut all of that off on the 28 to get a whole number, this probably wasn't exactly 62. So there were so many decimal places knocked off, but just for concept's sake, so that you understand the concept, that's the way you're going to do it.
So for a quiz, if we had a question where we could choose any one of the angles, wouldn't there be multiple answers?
They're all going to be within, if you're asked to,
Would there be multiple answers or one exact answer?
they're going to be, yeah, there's going to be multiple answers.
Okay.
If anytime you're rounding and you're using the numbers that you rounded in the next step, if you do a problem using a different number to begin with, you're going to get a different answer. But what you have to understand is that if your answer is 30.62 because you used this, and we got 30.58 because we used this, that you're doing it correctly. Does that make sense?
Yeah.
That's the important thing, is that you understand the concept and you're doing it correctly. Not the hundredths of a decimal place. Okay? And you have to understand that in math, when you're rounding, you're going to get answers that aren't exactly the same out to 10 decimal places. As soon as you round, you affect your answer. And as long as you're within certain parameters. Now, if you would have came up with 40.62, you did something wrong. Okay? That's what you have to understand. Y'all need to see another one? Okay, let's do one more. Take a look at, let's do this. Let's call it FED. E is your 90-degree angle, F is 58 degrees, and that's too easy. No, let's not do that. Let's undo that. Well, you have to practice. Let's make this 14. Make that 7. This would be a good. What kind of triangle is that? That's too easy. What's angle F? No, that's not too easy. If the hypotenuse was 14, it would be too easy. Because then it would be a 30, 60, 90, wouldn't it? Remember in a 30, 60, 90, the short leg is half the hypotenuse? So the converse of that, if the short leg is half the hypotenuse, then it would be a 30, 60, 90. Okay, so let's solve the triangle. Solve the triangle. So I'm going to find angle F first. And we're dealing with opposite and adjacent, so tan -1, 14/7. $63.4 degrees, so we're going to use 63 degrees. That makes angle F 63 degrees. That makes angle D 27 degrees. And I'm going to use the, let's see, let's use the 27 this time so we can use cosine. All right, so in relation to the 27, we know the adjacent, and we're looking for the hypotenuse. Adjacent and hypotenuse is cosine. Cosine 27 equals adjacent over the hypotenuse, which is FD. You can multiply both sides by FD to get it out of the denominator.
What did we do yesterday? Oh, we put it over 1.
Put it over 1 and did all the steps. We're just shortening it up today. These cancel. And then you're going to divide by cosine 27. Your cosine 27s cancel. And your FD is equal to, that's 14 divided by 27 cos. And that's 15.71. So we solved the triangle. Make sure you push equals at the end. Okay? So take your black calculator if you got one. Just try this for a second. Take 14, push divided, push 27 cos. And don't push anything else. And what does your screen say? 0.89. I've seen people write that answer down.
No, it's 15 points.
I understand. You have to press equals because what they're doing, they're telling you what cosine 89 is.
Yeah.
But I've seen it happen where when you push that cosine number, it kind of is similar to the answer. Don't forget, you push equals at the end. All right, always push equals at the end. So I got 15.7, well, second, fix 2, 1571. All right, any questions?
What'd you have for dinner last night?
I'll get back to that here in just a second. Page 555. 7 through 15. And then on 556. (27 through 35). Don't forget to check Edline for homework. And be sure you're keeping your notebooks up to date.